Today, we are diving into one of the biggest, most exciting dreams in all of tech, building a single robot that can do, well, just about anything. But as you're about to see, that dream has been way, way harder to pull off than you might think.
I mean, really think about it. It's a wild question, right? We have AIs that can generate flawless code, write poetry, create art, all from the neat, tidy world of a computer. And yet, getting a robot to do something as basic as loading your dishwasher is still a huge challenge. Why is that?
Well, it's because our physical world, your kitchen, your living room, it's infinitely messy and unpredictable compared to the clean, logical world of ones and zeros. But today, we're going to talk about the story of a major breakthrough, a huge leap forward in this quest for a real, honest-to-goodness, general-purpose robot. So to really get why this new development is such a big deal, you first have to understand the giant wall that robotics researchers have been banging their heads against for years. I like to call it the one robot per task problem. Think about it like this. If you want to build a robot that sorts packages in a warehouse, you have to basically build a whole company around it. You need new hardware, totally custom software. You got to program every single little movement. Then, if you decide you want a robot that can help in a kitchen, you throw all of that work away and you start from scratch. It's a trap, and it's kept robots from becoming a part of our daily lives. So how do you break out of that trap? Well, researchers at a company called Physical Intelligence are chasing a really ambitious goal. They want to create a universal brain for robots, a single foundation model, kind of like the big language models that power AI assistants, but for the physical world. The dream is to have one core intelligence that you can just plug into any robot for any task anywhere. And to test this huge idea, the researchers gave themselves what seems like a simple task, but is actually a monumental challenge. A chore we all know, and let's be honest, most of us dread: doing the laundry. It might sound easy, but for a robot, it's a complete nightmare of wrinkles, fabrics, and chaos. So their journey started out pretty simple. Back in March, they were just teaching a robot to fold a single, perfectly laid out shirt. Easy enough. By June, they cranked up the difficulty, starting with a crumpled shirt. And that right there is when they hit a brick wall. For months, July through August, they were stuck in a cycle of total, demoralizing failure. For long stretches of time, their success rate was exactly this: 0. Nothing. The robot would try, it would poke at the shirt, it would do things that kind of look like folding, but it just couldn't handle the randomness of a simple, crumpled shirt. They were making absolutely no progress. Just listen to co-founder Chelsea Finn. She said, "We frequently were getting 0% success rate and really struggling to make progress. It felt like maybe this problem was just too hard." They tried everything, giving the robot a better memory, higher-res cameras, you name it. Nothing was working. And then, a breakthrough. In September, they stumbled upon a new recipe, a new way of teaching that finally worked. And the idea, funny enough, was borrowed from the world of language AI. It came down to this two-part recipe. First, you pre-train the robot's brain on a massive, super messy dataset of all the robot data they had. Not just folding, but everything. This gives it a broad sense of how the world works. Then you fine-tune that brain with a small, perfect set of high-quality examples of the one task you want it to do. And the results were just night and day. If you look at the chart, you can see that trying just one of the methods, either the messy data or the perfect data alone, got them almost nowhere. But when they combined them, pre-training and fine-tuning, performance just shot through the roof. The robot could finally, reliably fold clothes. This new recipe also let them take a massive leap in scale. Before, they were stuck with a pretty small 100 million parameter model trained just on laundry. Now, they could use a giant 3 billion parameter model pre-trained on everything. And that bigger, smarter brain just learned way faster and performed way better. So the laundry recipe worked. Awesome. But the real question was, is this a one-trick pony, or is it a truly general-purpose recipe? So the team immediately started throwing a whole new range of tasks at it, using the exact same method. And check this out. Using that same pre-train and fine-tune recipe, the robot learned to scoop coffee beans, build a cardboard box, clean up a messy table, and even something as delicate and precise as lighting a candle with a match.
This proved it. The recipe wasn't just for laundry. It was a general-purpose way to teach a robot physical skills. Okay, this is incredible progress, but it immediately leads to the next big question, right? All these tasks were done in a lab it knew. Can this intelligence actually generalize? Could the robot walk into a kitchen it has never, ever seen before and still figure out what to do? Now, to get there, they first had to make sure the robot really understood what we were saying. For a while, the robot would kind of hear a command but then ignore parts of it. But with some new training, it started to get nuance. You could say, hey, clean up only the trash, and it would correctly grab the soda can and the wrapper, but leave the dirty plates alone. That's a huge step. So with that new level of understanding, they put it to the ultimate test. 3 random Airbnb homes that the robot had never been in before. And the results were seriously stunning. The robot hit an 80% success rate on different cleaning tasks, proving it could take what it learned and apply it to totally new spaces. Now, an 80% success rate is amazing, but it also means there's a 20% failure rate. And honestly, looking at the failures is just as interesting and sometimes pretty funny. It gives us a real peek into where the limits of this technology are right now. So here are some of the team's favorite failures. The robot would get tangled up after driving over a shirt. Or, get this, after perfectly folding a stack of clothes, it would just push the whole stack right off the table. It has a really hard time picking up thin objects, like a cutting board lying flat. And my personal favorite is when it just gets confused about what things are. In one case, it was told to put a spatula in a drawer, but as Chelsea Finn explains it, quote, it decides that the oven looks a lot like a drawer, and so it opens the oven and tries to put the spatula right inside. It's a great, funny reminder that this intelligence is still learning all the little details of our world. So what's the big takeaway from all of this? The journey proves that just having tons of data isn't enough. That's necessary, sure, but it's not the whole story. The real secret, the key that finally unlocked true physical intelligence, was finding the right recipe, pre-training on everything for broad knowledge, then fine-tuning on the specifics. This breakthrough is a massive step toward creating a true foundation model for the physical world. It opens up a future where robots could learn to do almost anything. And that leaves us with one final, really exciting question to think about. What should we teach them to do next?